Now that we've taken some time looking at graphs and their characteristics, now let's look at the more algebraic end of rational expressions. And today we're going to add and subtract rational expressions, getting ready to solve equations over the next 2 lessons. So we will be splitting those up a little bit for extra practice. So before we add rational expressions with variables in them, we need to remember what our rules are for adding and subtracting just straight out fractions or rational numbers. So the biggest thing is when we multiplied and divided, we didn't really care about the denominator so much as what order we were multiplying our parts in. When we're adding and subtracting, however, we do need to make sure that we have a common denominator before we can combine our fractions. So when we did this with our just straight out numbers, we need to think about what our least common denominator would be, and we usually just multiply in that extra factor to change the way that our fractions look so they have the same denominator. So in example 1, I have 1/2 and 3/4. Well, my common denominator would be 4 because I'm looking at my factors, and again, that's going to be the least common multiple between 2 and 4. So that means my 2, the denominator, it needs an extra factor of 2. So I'm going to multiply a 2 in both the numerator and denominator. Because again, I need to multiply by the same thing, numerator and denominator. In essence, I'm just multiplying by 1, which means I'm changing what the fraction looks like, but not what the value of it is. So simplifying that out, I need to multiply straight across. So that would be a 2 over 4. I didn't do anything to the second fraction, so that's still 3/4. Excuse me. And let's make sure my microphone's in the right spot. And then now I can combine my fractions by just adding my numerators. And so we're going to have 5/4. And again, we want to leave these answers as an improper fraction. So please do not write these as a mixed number. If you need to use this in another problem, having it as an improper fraction is definitely going to benefit us more than having to convert back and forth between a mixed number and improper fraction. Alrighty, in example 2, my denominators are 3 and 7. Now, unfortunately, I don't have any common factors with those, but I still need to get that common denominator. So in the first fraction, I'm going to multiply in a 7. And in my second fraction, I'm going to multiply in a 3. In essence, I'm finding the factor that I'm missing to make a common denominator. And so simplifying that out, I'm going to get 14 over 21 for my first fraction, and then 12 over 21 for the second fraction. And now I can combine them. 14 minus 12 would give me a 2 over 21, which I cannot simplify. Alrighty, example 3, I have 6 and 8. Both of these have a factor of 2, but then they have an extra factor that's not going to quite match up. So again, I need to create a least common multiple between 6 and 8. So what number are both of those a factor of? Well, they're both a factor of 24. So for the 6, I'm missing a 4. And the 8, I'm missing a 3. So that takes it out to 20 over 24 minus 3 over 24, otherwise known as 17 over 24. Alrighty. So in each of the examples that we just did, before we added our fractions, we multiplied in an extra factor to create the least common multiple. And when we start looking at expressions that have like variable expressions like trinomials or binomials, whatever polynomial we have, we can still do the same thing if we know what our factors are. So again, this is why factoring is so important for this unit. So again, if you're still not feeling comfortable and you haven't done so already, go back and review the factoring from unit 3, or you can go onto my YouTube playlist and look for anything that's 3-. That's all of our factoring ideas that we looked at before. So let's look at finding this least common multiple with variable expressions first, and then we'll add expressions that have variables or polynomial expressions in them. So again, we want to know what is the least common multiple between these terms. So I need to make sure that every single factor is represented in that least common multiple. So 2 and 5, I need a number that both of those go into, which is going to be a 10. Now, x to the 4 compared to x squared, well, x squared goes into x to the 4, so I'm going to include that one. Y cubed and y to the 5th, well, the biggest thing up there, y to the 5th. Okay, example 5. Again, I want to make sure that every possible factor is represented. We have 3 and 4. The least common multiple between those two is 12. Okay. Now I'm looking at my variables. I don't have any x's in that first expression, but I do have x cubed in the second expression. So I need to make sure that x cubed is in my least common multiple. So I am going to include it. Then with my y's, again, y cubed and y, the highest one is y cubed. So that's what we'll include. So let's look at this with factors now. So for this, we actually need to factor out these expressions to know what we're working with. So x squared plus 4x plus 3 would factor out as x plus 1 and x plus 3. Let me switch up my color for the second one. So second expression, x squared plus 3x plus 2. Well, now I'm going to look at positives, so x plus 1 and x plus 2. So when I'm thinking of this with factored expressions, again, I keep going back to making sure that every single factor is represented at least as many times as you see it in each expression. So if I go step by step through my expressions, let's see, both expressions have an x plus 1. I need to include that. So least common multiple. I need to include the x plus 1. Okay. And I'm starting by reading through that first expression. So we had an x plus 1, I included it. We have an x plus 3, I'm going to include that too. Now every factor from that first expression is included. Now looking at my second one, I have 1x plus 1. Do I already have 1x plus 1? I do. But I don't have an x plus 2, so now I need to include that. So my least common multiple would include all 3 of these factors when I try to put this into adding or subtracting expressions. Okay, example 7, same thing, we got to factor it first. So first expression factors as x, let's see, 18. We could do a 2 times 9, that's not going to get there. 3 times 6 would do it. So if we did a minus 6 and a plus 3, that gets us our correct factors to negative 18. My second expression, x squared minus 7x plus 6. So we could do a minus 6 and a minus 1. That would give us our negative 7 in the middle. So our least common multiple, again, make sure everything's represented. Reading through the red factors first, I absolutely need to include an x minus 6 and an x plus 3. So then read your second set of factors. We already have an x minus 6. We have at least one represented. We're done with that factor. But x minus 1, I don't see anything in that least common multiple. So I need to include that. So when we're thinking of doing this with expressions, actually adding or subtracting rational expressions, think in terms of which factor are you missing from your LCM, from your least common multiple, to make the expression work. So what I'm going to do is I'm actually going to do all of the even examples. I'm going to leave it to you to try the odd ones. So try those out and then come back and look at the completed version of the organizer to see how you did. Alrighty, so here we go. Example 8, we're going to start pretty simple. We only have a single factor. I am going to go ahead and write out my least common multiple just for my reference. So least common multiple in this problem is going to have to include both an x and a y. So I'm going to multiply in whatever's missing from that LCM in each expression. So 3 over x, my denominator does not have the y. I need to multiply that in. In my second expression, 5 over y, the denominator is missing the x, multiply it in. So now multiply those expressions and then we'll be able to add them up because they'll have the same denominator. And I always like to represent them when I have multiple variables. I tend to go alphabetical order. So I am going to list these as xy in the denominator. First expression now is a 3y over xy. Second expression is a 5x over xy. Now again, I don't want to simplify out at this point. The whole point of multiplying in those extra factors was to make sure we had the same denominator. So we now have that. Now I can add my numerators. So my final answer is going to be 3y plus 5x. I can't do anything to combine those, so I'm just going to leave that. My common denominator was xy, and that is my simplified answer for adding my two fractions. Again, doesn't look quite as pretty. We do have some more complicated terms, but we now only have one rational expression, one fraction. Alrighty, example 10. So again, I'm going to leave the odd ones for you to do, but come back and check the completed notes to see how you did. Okay, example 10. Find the least common multiple or the least common denominator. Again, however you want to express that, whatever makes you remember it better, go for it. Sometimes I use LCM, sometimes I use LCD. I'm going to tend towards using LCM this year just because LCD monitors, it has a double meaning. Okay, first expression has a y squared. I need to include both of those. Second expression has a 5yz. So I already have the 5 represented, already have a y represented. I need to multiply in a z. And actually, let me move this over because what I'm noticing is in this problem, I'm missing something in each expression. So in my first fraction, I'm missing the z, so multiply that in. In the second expression, I'm missing an extra y, so multiply that in. Alrighty, so now multiplying those expressions again, I like to express in alphabetical order. I'm going to express it just like I did with my least common multiple over on the right. So we're looking at 12z. That's why I put crosses through my z's so they don't get mixed up with the 2's. And then we have 5y squared z. Again, don't simplify out that z because then you don't have an LCM anymore. Okay, second expression, 2y over 5y squared z. Alrighty, our denominators are the same, so combine your numerators. So we have 12z minus 2y divided by 5y squared z. There we go. Alrighty, again, try out 11 on your own, but just to get you started, we have 3 expressions. We can still do an LCM for 3 terms. Again, start with your first, well, look at your numbers first. So you have a 6, an 8, and a 2. Again, what number could all of those go into evenly? Looking at a 24. So your LCM is going to be 24. And then look at your variables. So I have an a and a b in the first denominator. But then when I look at the second and the third, they have the a already represented and the b already represented. So what you're going to do is multiply in what's missing from 24ab. What do you have to multiply each fraction by, numerator and denominator, to make sure you have that common denominator in each one? Alrighty, so let's do number 12. So number 12, now we have expressions. So we need to factor these out first before we can determine what our LCM is. So factoring out our first denominator, we have an x plus 3 and an x minus 3. Second denominator, x plus 3, x plus 3. Okay, so our LCM is going to have 3 terms in it. So my first expression has an x plus 3 and an x minus 3. I need to include both of those. So x plus 3 and x minus 3. But then looking at my second expression, it has 2 x plus 3s. So my LCM is actually going to need 2 of those to make sure every single possible denominator is represented in that LCM. So we need to multiply in what's missing. Here we go. So the original problem was x over, and actually let me write it this way, x over x plus 3, x minus 3. So the thing that we're missing from our least common multiple or least common denominator is the extra x plus 3. So I'm going to multiply that in. Alrighty, second expression. We had a 3 over our factored version, x plus 3, x plus 3. The only thing we're missing is the x minus 3 to make it a common denominator. So x minus 3 and x minus 3. So now that we multiplied in our extra factor that we were missing, numerator and denominator, Now we're ready to start combining. And so in this step, I'm going to go ahead and distribute each expression. So I have an x times x plus 3 in the first numerator is really an x squared plus 3x all over our least common multiple. And I'm going to abbreviate and write LCM. Now be careful when you do this. If you write LCM in a final answer, you're going to be incorrect because you need to state exactly what that expression is. And so I'm just using this as a placeholder while I'm simplifying to save myself a little bit of time. My second expression, 3 distributed over x minus 3, so 3x minus 9 over the LCM. And so then if I combine my terms now, I'm adding everything from that second expression. So I have an x squared, no other x squared to add it with. I have a plus 3x plus another 3x from the second one, so plus 6x. And then we have plus a negative 9 or minus 9. And that whole expression is over the LCM, which I can now go ahead and write out. So x plus 3 squared times x minus 3. Now, the other thing that we may want to check on this is we now have an expression x squared plus 6x minus 9. Wouldn't be a bad idea to double check, can we factor this? Now, if we're looking at negative 9, trying to get to a positive 6, let's see, our possible functions, we could have a 1 and 8, which won't get us to 6. Only other, or 1 and 9, which won't get us to 6. Only other possible factors are 3 and 3, but to get that negative 9, one would have to be positive and negative, and we won't have the 6x in there. So even though I didn't write it out, I know that that numerator does not factor. And so I'm as simplified as I can get with this expression. And it is just fine to leave your denominator in factored form. Keep in mind, this is very closely related to all the graphing problems that we were doing, in which case it's really helpful to know what all the factors are if we're going to have to go ahead and graph this expression at any point. Alrighty, so try out the same thing in example 13. Your hint is if you look at that second denominator, you actually have a common factor that you could take out from 4, 16, and 16. So don't forget when you're factoring that out to find your LCM that you are factoring out that common factor of 4 before you do anything else. Again, check back to see how you did if you try that on your own. And our last example, number 14. So again, LCM, but I got to factor stuff out first. First denominator, difference of squares. So I have a 2a plus 3 and a 2a minus 3. Second expression, I have a 2a and an a. So to get that negative 3, well, let's see, I know one has to be positive, one has to be negative, and my only factors are 1 and 3. But to turn that into a positive a, that means I need to have a 3 here and a 1 here. So if I add the 3a and subtract the 2a, that would give me my positive a in the middle and still give me my negative 3 at the end. So my least common multiple, my LCM, all the factors I need, well, I need a 2a plus 3. I need a 2a minus 3. But now look at your second factor or your second denominator. What's the only factor we're missing? A minus 1. So now we're going to rewrite multiplying in what's missing. First fraction, 2a over 2a plus 3, 2a minus 3. We're missing, come on, switch over to red. There we go. We're missing the a minus 1, so multiply that in numerator and denominator. Minus 1 over 2a plus 3, a minus 1. What's the only factor we're missing? We're missing the 2a minus 3, so multiply numerator and denominator. Alrighty, go ahead and distribute out your numerators before we keep going. First one distributed out gives me a 2a squared minus 2a all over our LCM minus, so be careful with our signs in our next step, 1 times 2a minus 3, that's just 2a minus 3 all over our LCM. So now we're ready to start combining. Now we have to be careful. We are subtracting the entire second fraction, so I'm actually going to put parentheses around this to remind myself I'm subtracting each term. So let's see, 2a squared, I don't have anything to combine that with. But look at your 2a's. I have a negative 2a in the first term, or first fraction, minus the 2a from the second one. So negative 2a minus 2a really is negative 4a. And then we're subtracting a negative 3, which is really plus 3. All over our LCM, which is 2a plus 3, 2a minus 3, and a minus 1. And again, wouldn't be a bad idea to check your factors on this because we have our, multiple terms. I'm going to go ahead and do some brainstorming on here. To factor that numerator, I would need to look at the first and last term. So 2 times 3 would give me 6. And so brainstorming factors of 6, I have 1 and 5. And I have, let's see, 2 and 3. And unfortunately, none of those are going to come together to make that negative 4 in the middle. So that is simplified as far as it can go. So again, try out the remaining examples on your own and check the finished version as you're done.